In this video, we're going to take a look at another very important concept. It's a very small and simple concept, but it is one of the cornerstones of modern deep learning. So it's really important that you understand it. And it's such a simple concept, but it's very counterintuitive, so people find it difficult to understand. So we're going to motivate this visually. Let's take a look at this image over here. Let's say we're trying to train the machine to recognize the images of bananas. You may show it many banana images, but the problem is that machines have very good memory. They can simply memorize the pixel values, and if you show it this image again, it can simply recall from memory that this is a banana without having to actually what is called learning. No learning is going to be performed, and the machine can simply memorize this, right? So that is called overfitting. What we want to do instead is to reduce this aspect of overfitting by hiding some of the information from the machine. So for instance, we're not going to show the machine this image to train, we're going to show it this image. Right? So some of the portions have been blocked out, right? Or blacked out. So when the machine gets this piece of information, now it must somehow fill in the blanks over here, and that would require learning on the machine's part. If in the future we show it the complete image, these pixels are going to be new for it. And the machine would really have to learn something in order to recognize that this image is the same as this image, right? So this concept of blacking out or blocking out some pieces of information before giving them to some layer in the machine is called a dropout. Right, so we drop out some of the pieces of information, and the way we do that is simply when you have one layer's output coming out, you set some of the values to zero. Right, so setting the values to zero essentially turns it into a black portion for the machine. So machine cannot learn from those specific pixels, and in order to really generalize the learning, the machine has to understand the underlying concept of what a banana looks like. Right, so it has to understand the underlying ground truth, and that helps us achieve much better results. So dropout is one of those aspects which is really easy to implement. It's really easy to understand once you get the intuition behind it, and once you do understand it, it will be a really powerful tool to have on your side. And how do you use it? As before, Keras to the rescue. We have from keras.layers import dropout. We run that, and in your existing architecture, wherever you want to do the dropout, for instance, we want to do a dropout after this pooling layer, so we can simply go ahead and say model.add, and we say dropout. Oops, dropout, and then we give it the percentage of the pixels that we need dropped out. So for instance, we can say 0.2. So for that, 20% of the pixels coming out of this layer are going to be set to 0. Right? So those are going to be dropped out. And simply by that, you help your machine generalize the results from this to this, right? So the machine will now be learning this portion over here, and we can say that the machine really is going to learn what the underlying architecture of a banana is before it can go ahead and predict the future banana images, right? So we can go ahead and run this, and you will notice then in this layer there is no change, right? There are no parameters to learn. Right? So there are no parameters to learn in this dropout layer because no operation is being performed other than simply setting 20% of all the values to 0. So this is a very fast method of making your machine really understand the concept by generalizing it and reducing the overfitting. So this is one of those things that you really want to understand, and you really want to make sure that you use it in your architectures because it really helps you avoid the very general problem of overfitting.